Hey everyone, in this video we are going to solve the question of right view of binary tree on Leetcode. So what we are given here is a binary tree and we have to print its right view. So what do we mean by that and how we can solve it? Let's see. Okay, so we are given here a binary tree and we have to print its right view. So what do we mean by its right view? So if someone is watching from the right side of this binary tree, what will he see? He will see the node 1. He will see the node 3, but he will not be able to see node 2 because it will be hidden by the it will be behind the node 3. Similarly, on the next level, he'll see node 4, but he'll not be able to see node 5. It will be hidden behind node 4. So the output in this case will be 1, 3, and 4. So how we can do that? We'll use a JavaScript object literal with key value pairs, and each key will represent the node at that particular level. So if we see node 1 is at level 0, and at node 2 and 3 are at level 1, and node 5 and 4 are at level 2. So we'll do a particular kind of traversal in this case. So first we'll traverse the root, then right, and then the left. Why so? Because we want to get the right part first. So what will happen is we'll start traversing from this node root. We'll start traversing from a root node 1, and we'll check if for level 0 we have any value or not. No, we don't. So what we'll do, we'll add a key value pair. So a key of 0 and a value of 1, because the node at level 0 is 1. Then we'll go to the right side here. So on right side at level 1 we have node 3. So we'll check in our object, do we have any value at level 1? No, we don't. So we'll just add here level 1 and the value 3. Similarly, we'll go to the right again. So we'll check for level 2 node 4. So for level 2, does any value occur? Does any value is there in our object for level 2? No, we do not have any value at level 2. So we'll store the level 2 and the value at here 4. Now we'll go back and see the left part. So for 3, do we have any left child? No. Then we go back to the root 1. Do we have any left child? Yes. And it is at level 1. Now we'll check for level 1. Do we have any value in our object? Yes, we have. We have a value of 3 for level 1. So we'll not update anything. Similarly, when we go to the right child of 2, we have a node 5 which is at level 2. We'll check for level 2, do we have any value in our object? Yes, we do. We have a value 4. So we'll not update our object, will not do anything. And then we'll go back and check, do we have a left child of root of node 2? No, we do not. So we don't do anything. So what we are doing, we are traversing the right part first and updating our object with key value pair. Key means the level, and value is the node at that particular level, the right node at that particular level, and will only update the object if that particular key is not present in our object. So if we only added 1 colon 3 when we didn't have any value at level 1 in our object, so we get the whole thing, and in the end we'll just return all of these values as the output. So the time complexity for this problem will be O of n, and space complexity will be O of h, which is the height of binary tree. So let's see how we can do it in code. Okay, so first we'll just write our first check. So if the root does not exist, if the root is none, just return an empty array. So we'll return an empty array from here. Now if the root does exist, first let's declare our result, our object, our object literal. Then we'll run a dfs function. We'll write this dfs function soon, and we'll pass the root, the current level, and the result object as arguments. And then after that, so once our dfs function runs and update the result object, what we'll do, we'll just return all the object dot values of our result object. So let's write this dfs function now. So where dfs, now it will be a function, and it will take three things: root, level, and the result object. Now we'll just check if root does not exist, we'll just return from here. But if the root does exist, what we'll do, we'll check if we have a value for that particular level in our object or not. If the value for that particular level in our object is not available, is undefined or null, so we'll check if result at level is equal to null, or if result at level is equal to undefined. In that case, what we'll do, only in this particular case we'll update the key value pair in our object. So for that particular level, we'll store root.val. So what we are doing here, so we don't have any value at that particular level in our object. If that condition is true, only then we are updating our object, and with level as key and root.value as value. Now we'll run the dfs function, and first we'll traverse the root.right, because as we discussed, first we go to the right part and then to the left. Next we'll increase our level by 1 and pass the result object. Next we'll do the same thing for root.left, then level, update level by 1 and the result object. Okay, so remember, first we need to go to the root.right child. That is the key point for this particular question. So first we run dfs on the right child and then the left. So if I run this, it's working. Let's submit it. It's working as well. So that was it for this video. Thank you for watching.